So let's show this with base 10 blocks. Now to do that, it's nice to have the blocks in your hand or have some virtual ones that you can play with. Drawing them, we want to be much neater. Attempt to draw them here, so I'll add a grid to this in a moment. So how many groups of 7/10 are in 3 and 5/10? So I want to take 7/10 into 3 and 5/10. And I want to visualize that with base 10 blocks. So the base 10 blocks, one standard way we've been doing that is that grid. Shrink that grid down. Sufficient. So I'm going to draw out a 10 by 10 grid to show a hole. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 that way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 that way. If you don't have access to graph paper, get out a ruler. Have a ruler, fold a piece of paper in half and make one. So I'm going to say this is going to be my one hole. So then this here would be 1/10 of that. Fortunate enough to have digital paper here that I can reproduce this easily. Oops. There we go. Together. Copy. So I want 1, 2. Yeah, it's a little tedious doing it by drawing. So I'd highly recommend using some toys, physical or virtual. Not just as much work drawing these by hand as it is reproducing them. One, 2, 3, 4, 5, 6, 7. And then drawing the 3 and 5/10, I would use this one over here. So there's 3, 1 for 3, 2 for 3, 3 for 3, 5 of these guys. Interesting. Just have to wait one buck. So I need to figure out how many of these live in there. I'm going to step away from this one for a minute and look at some virtual toys that are easy to play with, almost like using toys yourself. The Learning Center has some great apps that are free to use online. Their number pieces app. Let someone use the colored version. And given that there's only 2 places, you have a couple of choices. So my previous one, I decided that was going to be a hole. A little bit. Alternatively, we can decide this is going to be a hole, and these guys could be 10s. So there's a couple of different options. I'm going to go with the previous one. I think it'll fit on here. There's a duplication tool around here if you have one selected, which is kind of nice. 3, 4, 5, 6, 7. How many times that goes into 1, 2, 3. Let's grab 5 of these guys. Select multiple ones here with the shift key after the first selection. There's my 3 and 5/10. So to do that, I have to rethink this as these are the individual things I'm looking for, so I need to break these guys up to make that happen. So this has a lovely feature. Select a bunch, and then I can break them apart. So this right here is still my 7/10. The 5/10. Document what we're doing. And then I just need to start looking for groups of 7/10. So there's 1, shift key to select others, 2, 3, 4, 5, 6, 7. Right, 1, 2, 3, 4, 5, 6, 7. And let's colorize them for fun. So we'll make those yellow. And then 1, 2, 3, 4, 5, 6, 7. We'll leave those green. Next one, now hold shift. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Next group starts here. Shift. 1, 2, 3, 4, 5, 6, 7. Alternate color to see them better. I'm going to label this. There's a pen here. So here I have one group of 0.7. And here I have another group of 0.7. Another group of 0.7. Right with my mouse, right with me. One more group of 7/10. So altogether, I found 7/10 goes into 3 and 5/10 5 times. So that is our idea of how long division works, or division works with decimals. What it involves is thinking about the decimal as a whole number of things instead of a fractional number of things. So once I get my picture drawn here, I have 7 things here. And I'm trying to figure out how many times those 7 are grouped inside this here. And here, there's 10 of them there, and 10 of them there, and 10 of them here, and 5 of them here. So how many times does 7 go into 35? 7 goes into 35 5 times, with none left over. So that's the essence of decimal division. We have to think in terms of a whole number and adjust dividend accordingly